Welcome to solverfy.
So problem 8.99, the setup here is there's a bandit of some who has loosed a wagon containing some gold and is planning to have it roll off this cliff where his friends can then take the gold and then they get away with it or whatever and become rich. Total mass of that is 300 kilograms. It starts off rolling down this shallow incline, but then 40 meters from the cliff, the Lone Ranger and Tonto drop onto the wagon and are hoping to be able to grab the gold and get it off the wagon before it goes over the cliff. However, we're told that it takes about 5 seconds for them to get the gold and jump out, and we need to find out whether the wagon will go off the cliff within that time before they can escape. And then we're also curious of whether the kinetic energy of the wagon and the heroes is conserved, and if not, how much does it change by? So for our first part here, we want to figure out how fast the wagon is going before they jump in. And so this is a conservation of energy thing. So the initial potential energy from it being up this height is going to be equal to the kinetic energy once it's rolling on the ground with negligible resistance. So mg times, now we have the height of this is going to be 50 meters times the sine of 6 degrees. This is going to be equal to the kinetic energy, so 1/2 m v squared. And just solving this for v, we can see that v is going to be 10.12 meters per second. Now for this collision, we can think of it as a collision. We need to use the conservation of momentum, like in every sort of collision problem. And now what we would expect to happen is they have 0 momentum in the x direction. And so in order to, but they have mass. And so in order for the center of mass of the system consisting of the 2 people and the wagon to be moving at the same velocity, this will have to slow down. So we have, now let's call the wagon A and both of them together B. So MA times V, we've called V here, is going to equal the mass of the wagon plus the combined mass of the Lone Ranger and Tonto times its final velocity, or speed. Now solving this for VF, we have that it's equal to the ratio of the initial mass of the cart to the final mass. times how fast it was going to begin with. And so that's 6.98 meters per second. So now 6.98 meters per second times the 5 seconds they have to take is 34. Well, maybe we'll make that look like 3. 34.9 meters. So they can get off the wagon before it goes over the cliff. Can get off safely. Now, we know how fast the cart was going to begin with, and we know how fast it was going after they jump in. And we're to assume that they jump in from a very short height, relatively speaking, and so they don't really have any kinetic energy of their own. And so now we want to see what change, if any, there is in the kinetic energy. And since this is an inelastic collision, we sort of should know to begin with that the kinetic energy will not be conserved. So we need to find how much it changes by. So actually, let's just K final minus K initial. So the final kinetic energy is, we'll just take 1/2 out of everything so that we aren't dragging it around everywhere. MA plus MB times VF squared, and then its initial kinetic energy is just MA, what we call V squared. And so this is negative. If it's not negative, then we're in trouble. 4.8 kilojoules. So this is the amount by which the kinetic energy of the system has decreased from them jumping into it and staying in it. Not, if it were an elastic collision, they would have to somehow bounce off of it, which would be strange. So this is good. It makes sense. They can get out of the cart with the golden time. So everything has a happy ending.